My name is Nick. I work at the Global Facility for Disaster Reduction and Recovery, which is a team within the World Bank in Washington, DC. So I'm going to talk about how we have been trying to bring some more big data and remote sensing into planning for urban resilience. So as we're all aware, there is very fast urbanization occurring around the world, and we expect to see maybe 2.5 billion additional people living in cities by the middle of the century. A really critical issue, therefore, is how do we encourage the process of urbanization to take place in a way that is well adapted to the changing climate. And for that, we need data. So for a long, long time, at our organization and other international development agencies, working with, let's say, a city government on the ground to help them develop a new local investment program has been done through local consultants. Maybe an engineering group will come in and do an assessment of flood risk. Maybe they will take some aerial photographs. We are essentially looking at how can we accelerate the process of bringing good insights to inform that government's decisions, and can we use freely available satellite imagery to do the same faster? Can we also use machine learning to get us to those planning insights more quickly? So my talk today has two pieces. I want to quickly preview some work that we have done using only free and global data. So what can we get out of Sentinel, out of VIIRS, the other data sets that you could find on Google Earth Engine? And secondly, how do we move towards more cutting-edge computer vision methods and get them really deployed in the field? So this is Penang in Malaysia. It's one city that participated in a series of investment planning workshops that colleagues of mine organized. Picture the scene. You have a conference room, you have representatives of, say, I think they had 15 different cities from around the world. We're trying over the course of 2 days to stimulate a conversation about what are the major risks that your city faces and what are the investments that you might want to undertake. So our task that the GFDRR team tried to contribute to was how do we quickly create a set of maps and geospatial layers that will help have an informed conversation to answer questions like how has the city changed in shape? And is the growth pattern resulting in more settlements within the flood zone? So using only free global data, we can very quickly put together layers showing the elevation of each city. We can use existing products like the global human settlement layer to show back in 1975, Penang was concentrated up in the red area. We can see the spatial pattern of growth of the city. We have been trying to use OpenStreetMap to get, for example, the locations of schools and other pieces of critical infrastructure and see are they located in flood risk areas. But this work, which is still ongoing, is really aimed at trying to develop more layers that we can quickly produce. This one here is using nightlight data from the relatively new VIIRS data set. Here we take 6 years of the nightlight intensity. At pixel level, we plot a best fit curve, and we are plotting the slope of change from low to high in the color of each pixel. So this is a tool that runs really, really quickly and can show where has the concentration of economic growth been within the city. We're really hungry for more research and methods that we could bring into this work from the research community. For example, a lot of cities at the moment are trying to plan greening campaigns, especially those cities which are faced with heat wave risk in the future. Many of them are thinking, where is the existing city tree cover? If we had a baseline of that tree cover, we would be better placed to decide where more greenery is needed across the city. If anyone can crack this one and find a low-cost method to show us where the trees are, that would be great. That leads us to monitoring change in built-up area. So we're really keen to know specifically where are new buildings going up around a city. And for this reason, last month, we launched something called the Open Cities AI Challenge, which is a ML competition with some prize money. But I'm just going to show you the data set that we created. So the motivation is to map buildings in vulnerable areas. But why is this difficult in Africa or other developing regions? We don't have a lot of very good quality imagery that is openly available. And unlike, let's say, in the USA, where you can get a data set showing you the exact outlines of buildings that you could use to build a supervised model, we don't have those building footprint data sets freely available. Leading models are fantastic, but computer vision models trained on US and European data do not perform as well as they might do in Africa because the built environment is different. And then accessing imagery and labels is tough. So if we want to be able to deploy computer vision models a little bit like this one here, which is the result of an earlier competition, we really wanted to think, what are the steps in an open machine learning ecosystem that can help bring computer vision methods to the implementation edge. And for that reason, we have released this data set. So it's a new data set of really detailed drone imagery and building footprints from, I think it's 12 locations in Africa, collected via participatory mapping schemes that were supported by the World Bank. And the data set looks like that. We have very distinct regions and variations, but covering Ghana, Tanzania, and a number of other countries. And a key characteristic of what we've done is to focus on open source standards that will make it easy, we hope, for people to take up this challenge and develop methods that can be picked up into broader circulation. So the images are as cloud-optimized geotiffs, and we're quite enthusiastic about the Stack asset catalog standard. In short, we like this because instead of having to try and download a vast drone produced image to your laptop, which is going to break your laptop, with Stack and cloud-optimized geotiff, you can just pull the precise chips that you want of the images together with the labels that correspond to that image. The challenges with this data set, the images are from diverse locations and capture conditions. And we have two tiers of the labels. Just like in real life, we have labels of good quality, but we also have labels which are more like OpenStreetMap building footprints of lesser quality. And the contest is asking you to do two things. The semantic segmentation track is to identify building or no building. And it's hosted by Driven Data. So whoever gets the highest performing algorithm on intersection over union will share in prize money. And we have a responsible AI track as well to kind of grapple with the ethical issues that this technology brings. So in short, we're really enthusiastic about trying to do traditional international development work and urban development financing better through bringing in computer vision methods. We would really encourage anybody to participate in the competition. If you would like to do so, thank you very much.
Thank you.